So this is section 3.3. I'm on page 177, and this is number 27. And the directions were to graph each line and use the slope and y-intercept. And so when we graph this, first identify the slope. The slope is the number in front of x. We use m to say slope, that's 2, and the y-intercept is the b value, which is the constant at the end when solved for y. So the y-intercept is -3, or maybe better to write it as an ordered pair. The y-intercept is 0, -3 specifically. And so on our graph, when you make a graph, make sure you include tick marks, make sure they are somewhat equally spaced, or use graph paper. We've plotted a couple points. So we start with our y-intercept, which is -3. And we'll plot that point here. And then from that point, I need to count up 2 and over 3. So that's, up 2 and over 1. So then you may do a slope is always write it as a fraction to give you the cue that it's rise over run. So you count up 2, 1, 2, and over 1, and give yourself a point. And that's 2 points, so that makes a line. If you want to count another 2 and over 1, you can do that. And then if your tick marks are equally spaced, you should be able to draw a straight line that will go through those points. If you want to talk domain and range of every line is all real numbers. So you could say for domain, x is an element of all real numbers. And for the range, y is an element of all real numbers. Or if you're using interval notation, -infinity to -infinity for both domain and range. Okay, let's jump over to the next page. And on number 45, we want to write this in standard form. So to do so, we're looking to get in this form. And the directions also say, which is often the case with standard form, we want to use only integers and a positive coefficient for x. So we want to clear out these fractions. You can do this kind of in a couple different steps. First, let's just distribute this just to get rid of the parentheses. I think that may save a little bit of confusion. And now let's clear out the fractions. So you look at the fractions, we have a 2 and a 3. Common multiple would be 6. And so I'm going to multiply everything by 6. So multiply everything by 6, and I won't change the value of the equation. So 6y, and then 6 times 1/2 is 3. 6 times 1/3 is 2x, and then 6 times 4/3 would be 6 times 4, which is 24 over 3, which gives you -8. Then we got to get all this, or the x's on one side and the constants on the other. So I subtract 2x from the other side, and I'm going to subtract 3 from both sides. So that makes it -11 when I subtract 3 from -8. And then we want x to have a positive coefficient, so I multiply everything by -1, or you can think divide everything by -1, or you can just think let's change the sign to everything. And there is the same line up here, just in standard form. So we have standard form down here and point slope form here. Okay, and then on the next page, number 89, this will be the last one we look at in this assignment, is determine if they're parallel or perpendicular. So parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. So we have to identify slopes. This first line is easy because it's already in y equals mx plus b form. So we can say the slope is 3. Pardon the bell. Now the next line, we have to find the slope. So to find the slope, probably a number of different ways you do it. Most commonly, get that y by itself. So 3y is equal to -x plus 7. Those are unlike terms. Do not combine them. And then divide everything by 3, and you get y is equal to -1/3 x plus 7/3. In this question, we're not really worried about the 7/3. We just care about the slope. So m is equal to -3, negative 1/3. And we see that if 3 and negative 1/3 is, they are opposite reciprocals, excuse me. And if you don't believe me, 3 is 3 over 1. So I flip that over, I get 1 over 3, and the positive changes to a negative. So these are perpendicular. And this, just remember, this symbol means parallel, and this symbol means perpendicular. Okay, and that is it for this section. Good luck on the homework.